Switch triggered on agent kill switch made agent. The guardrail check stopped the agent before it could keep looping. Reason, I built an AI agent that handles production alerts. And if you saw that video, you know I'm big on stuff that keeps automations alive in the real world. This one is the flip side of that. Sometimes the thing that keeps your automation alive is knowing exactly how to kill it. AI agents can spend money, call APIs, and touch real systems all on their own. And when they get stuck, they don't crash, they loop. One team watched two agents ping pong requests at each other for 11 days straight and ran up a bill of $47,000. So I built a kill switch for my own AI agents and n8n, a hard stop that shuts things down the second they go off the rails. As always, free templates are in the description. If you appreciate this type of content, gently hit that like button and let's get to work. Quick context on why I take this seriously. I've spent years at production support dealing with P1, P2 incidents, and I've watched a very small thing turn into a very expensive thing very fast. And it turns out AI agents make this worse because they can take actions faster than a human can actually notice that something is wrong. Here's the part that nobody tells you. When you start building AI agents, they don't fail like normal software. Normal software crashes, you get an error, you know something's wrong. Agents keep going. A workflow gets stuck between two steps, decides to retry, retries again, and an hour later, you've called an API a few thousand times and nobody noticed because technically nothing broke. There was a documented case from earlier this year where two agents, one checking work, one doing work, got stuck passing a task back and forth for 11 days straight, running up $47,000 in API costs before anybody caught it. Around the same time, somebody posted about an agent that kept spinning up duplicate cloud infrastructure. Every time it hit an error, nobody told it to stop. And that turned into a $6,500 bill overnight. And it's not just enterprise scale stuff. This is showing up in n8n's own community forum. People asking how to stop an agent that's stuck calling the same tool over and over. It's common enough now that regulation is catching up. The EU AI Act requires a shutdown capability for higher risk AI systems starting this year. So this isn't a nice to have thing anymore. So what does a real kill switch actually need? Three things. First, a hard limit, and this isn't a suggestion. n8n's agent node defaults to 10 iterations, which still gives a stuck agent plenty of room to run up a bill before anybody notices. And even if you tell the model in the system prompt, hey, stop after 5 tries, that's just a suggestion. It can ignore it. So the limit has to live outside the agent's own reasoning. As an actual node, it can't talk its way around. Second, a cost or usage threshold, because iteration count alone doesn't tell you what you're spending. A handful of expensive calls can burn more than 1,000 cheap ones, so you want something tracking actual usage, not just loop count. And third and final, a way for a human to pull the plug manually immediately without redeploying anything. Because sometimes you're just watching something behave weird in real time and you want it stopped right now, not after you push a fix. All right, now let's hop into the demo. If you look at my screen, you can see that there was a few things from my last video. The alert triage agent, the heartbeat, and the error handler. This time we have a few more flows. The first one is the agent kill switch. And if we click into it, we can see it's very similar to the last one, but a few different things are going on. We can, when clicking execute workflow, it passes it off to an AI agent. And there's a chat model that's attached to this, guardrail check, check delivery status. We go off to an if statement and we potentially send a message to Slack. If we click into this AI agent and we scroll down, we can see that max iterations is set to 5. Now, the default is 10, unlike some Google searches that you'll see that will give you conflicting numbers. That's why it's very important to understand what your model defaults to. And let's also put some extra restrictions and come in here and change the settings. Let's push it down to 5 to make sure that we don't run up those API calls. Next, we can go ahead and let's throw on a guardrail check, the real cost tracking one. So we can actually come in here and say, hey, if we're going too high, we need to stop this call right now. So that way there's actually a shutoff point and real dollar amounts that we can be aware of. And finally, I have this side check delivery status. The mock tool prompt referenced a check that didn't actually exist. So, it's one of those things where real gotchas happen in these flows, and that's why you have to put precautions in them. Quick break, the full workflow, the kill switch nodes, a setup checklist is in the description and pinned comment below. Grab it and wire it into whatever you're already running. All right, let's get back to it. All right, now what's the next part? It's that kill switch. Definitely need it. Want to be able to say, all right, this agent needs to stop. Let's turn it off right now. So that's actually pretty simple to make. Let's jump into this flow, agent kill switch. Look it, it's only 2 nodes. So we have a webhook that's a get, kill agent, authentication, none, respond immediately. So if we listen for a test event and we throw this into a URL or we hit it with a curl, we can see now we have an output. And again, this is a test environment. I have to manually hit execute, but this would fire off in a production environment right away. And we can see that we have an alert that came out to the Slack demo, alerts demo in Slack. Manual kill switch triggered on agent kill switch made agent. Somebody hit the override webhook. Go check what the agent was doing and confirm that it actually stopped. You know, not only do we need somebody to hit the kill switch, but we also want to make sure that other people are aware and that somebody is actually verifying that that agent has stopped. As far as I know, it can be difficult to stop agents in flight. So once you hit a kill switch, that doesn't necessarily always mean that the agent has stopped. So we want to make sure that we have a real person that is aware of the situation and they are going in there to make sure that we have stemmed the bleeding. When I had tested this myself, it was about 64 milliseconds between hitting the webhook and going to Slack. So that's very fast response time to make sure that we have a human in the loop. And finally, to close out this demo, let's check out the real meat and potatoes. You know, building it is the easy part. The real question is, does it survive production? So let's check it out. So if we come back to the main workflow, and let's go ahead and try to execute it. So let's walk through it and we can see these nodes actually firing off in real time. And as this goes, it's going to keep going until it hits this guardrail and it sends a message out to Slack and it says kill switch triggered on agent kill switch made agent. The guardrail check stopped the agent before it could keep looping. Reason, guardrail check, item JSON response. So essentially, this guardrail was actually able to detect that we looped through multiple times and that the cost of the APIs was greater than what we had put in for it. So it was an automatic kill switch on the dollars amount. And now we can see that this flow actually does survive production. An agent with no limit, it's not autonomous, it's just unsupervised. And those are 2 separate things. Give it boundaries and it's actually production ready. If you want to find out more about how to monitor an AI agent once it's live, check out my next video on monitoring AI agents in Grafana. You can go check that out right here. Thanks for watching and I'll see you guys next time.